Everyone, we'll make a start. Thank you very much for coming along. There's some familiar faces, some new faces. So welcome new faces and welcome back everyone else. Today we're very lucky to have a couple of talks. A short talk by David, who's going to tell us about some of the work he's been doing, continuing from the last session, which was on sentiment analysis of text. And then we're on to the main event with Barney, talking us through some of the work he's done on image analysis and classification, and it's a chance for us to get hands-on and learn a bit of Tensorflow, which is something that's been on my to-do list for ages actually. So that'd be really good. So for about the first 20-30 minutes we'll be listening, and then after that we'll be kind of cracking on with having a go ourselves. If you need to kind of pop out to the rooms, they're just upstairs. There's some refreshments here, there's some outside. Fantastic. So I'll hand it over to David. Please welcome David. Thank you.
So back in January, we had a talk about natural language processing, and one of these fields is sentiment analysis, and we're introduced to the Python natural language toolkit and something called nltk.sentiment.beta, which is a module where it allows kind of words to be classified with either positive or negative sentiment. So if you have a set of reviews of something, then that would be potentially useful for that. But it'd be worth checking to see how useful it is actually in the real world rather than an idealised case. So this is actually what Veda is, and the number of features that it has a list of words that negate things. Because the trouble is that you might say that the word good is a positive sentiment word, but then if I said this game is not good, then that would then be negative. There's a function here where basically it will detect if you have a list of words, are any of them causing negation? And it's fairly sort of simple thing, and it's not really foolproof as we'll have a look. Where's it gone? That's the wrong tab. So I had a little bit of issue kind of getting this onto my laptop, so I'll kind of probably switch to just kind of looking at the images directly halfway through. So what I want to check is if you have a review, and then you can classify the words, see if they're positive or negative, and this is what it. So these are reviews which were beforehand labelled as positive. I'm not quite sure I'm getting the bit of centre of the page going right there. So these are all positive reviews, and these are basically every word that's in lexicon. So you'll see that positive reviews don't only have positive words, there are actually quite a lot of negative words as well. And visualising a data set of this size, you can't actually see because the dots are basically on top of each other. Nevertheless, you can then sort of compare it to the negative reviews, and negative you see it's got so it looks like a sticker line on the bottom half of the diagram compared to the previous page. But an even better, more quantitative way to look at that is to go to histogram, and I've been using the matplotlib set of tools in Python for generating the plots. So again, in positive reviews there are actually quite a lot of negative words, and vice versa. But there aren't very many of the most positive words in negative reviews. So once you get above plus 0.6, the negative reviews tend to contain very few of them. And then you can, instead of looking at all of the words at once, you can then sort of think, well, what's the median for each individual review? And then positive ones on the left, then there's a more predominance of positive in that plot. Whereas the negative, there's quite a widespread, but there's quite a lot of negative reviews with positive words. And that could be related to the negation, because this is the first sort of iteration, very naive, sort of look at the raw sentiment scores as they can. And here I've actually looked at the minimum as well. So in fact, there's quite a few negative reviews which have a minimum sentiment score in positive territory. But there aren't, so this is going to, then you can look at the maximum ones. So not many positive reviews have negative words and only negative words. This is where I'm going to switch to the other thing, because so that's the negative reviews and the maximum sentiment score. So some of them contain very positive words. That could just be one word in the whole review. So then you go to, oh, that's a different one. That's a different one completely. I've gone a bit ahead of myself there. Yeah, so that's a positive reviews there. Yeah, so the negative one here is the so the maximum score is often positive in the negative review, where there's no accounting for negation as of yet. And this is one sort of idea I had, is what about the change of the sentiment according to how long the review is? So what you see is that as it becomes longer, it tends to settle down to a particular median, which statistically you kind of expect that anyway, but it does kind of seem to, the positive reviews with negative words seem to drop off at kind of as length increases. Negative is actually a slightly different feature here. They actually have a bimodal distribution, so you'll find that the sort of as the reviews become sort of a medium sort of length, the sort of neutral median ones tend to become rarer, and so they either have sort of a slightly negative median sentiment or sort of slightly positive. And also the most extreme negative reviews are actually very short. It's not that the long rants full of negativity are the most negative language being used. It's actually the short and no, it's not. So this is actually what a review looks like. This is actually just kind of picking out the first one. And each word that's in lexicon has a score there, and that one is negated because this I've used a sentence tokenizer, which is part of NLTK, and it's fairly naive because once there's a single negation, then the whole sentence is negated. So really, to do negation in a more intelligent way, that kind of gets somewhat deeper into linguistics and actually possibly part of speech tagging, and that's probably a much longer talk than this one can be. So yeah, so this is actually the kind of the code that I kind of wrote to make sense of the reviews. So there, if you actually So NLTK has its own word tokenizer functions and a sentence tokenizer. So what I do is split up the view into sentences, and then for each sentence, if there's a negation in that, then flip the scores for the word sentiments. Now, that may not work with sort of long compound sentences, because you might be sort of based on a short part of it, you'll actually be negating everything, and also kind of lots of the sentences these are actually well formed, if you actually look into the file. What you actually then can do, once you've got the negation, you can then sort of that's the one. Just at the end now, I think. So these are what the plots look like once you've actually started to try to account for negation. So that's the maximum in negative reviews. So the trouble is that you can actually negate things that were negative words and make them positive. And there's not necessarily a symmetry between the two. But then to work out why that is, that's another deeper linguistic question. In the histograms, negative reviews now have kind of more negative words. To get to the other one, I think. It's, so I've got a slight problem with the kind of where I've actually put this. The right sort of window. So after accounting for negation, the positive reviews still actually have quite a lot of negative words. So the sort of naive approach to accounting for negative words is actually insufficient to actually avoid the problem that if you take a review, take its sentiment scores, it's not always absolutely clear whether it was a positive or a negative review.
There are review sites use this system, like Metacritic. It is better than the star system.
I think it is used in some ways in various other applications, but I think the message is that you have to be aware of actually using a sort of a naive application of something that you can get out of something like this before actually really understanding what you're actually putting into it. Because actually it can sort of lead to
Things
kind of
weird.
jazz. Okay, well, anyone else got any questions or comments?
Thank you very much, Dave. I think for me, what this has done is really shown how it's important to understand the validity of some of the models that are kind of put in front of you by APIs and libraries.
Yeah.
Last time we looked at a very deliberately very simple approach to sentiment analysis because we were kind of introducing ourselves to the method. And I think what you've done is really important in visualizing the limits of that system and showing actually the kind of your histograms were very much sort of had two big lumps on either side. So that tells us a little bit about, well, actually, do I really trust the score that I come up with? So I think that's really valuable actually as a lesson to us all to understand both our data and the performance of the models that we're working with. And just thirdly to say thank you very much for doing this. We always welcome members of the community who are kind of learning and taking their early steps in some of these ideas and sharing what you've done and sharing what you've learned and the steps you've gone through.
I think one of the cases that I saw was when there was some credit review that was actually spending most of its time talking about how awful a different game was. So it might have actually been positive about the game that was being reviewed, but from a scoring standpoint, it would actually turn given negative numbers.
And I like the little insight about short reviews tend to that be negative. Great. Thank you very much, Dave. And handing over to Barney, I'll let you introduce yourself actually.
Right, Neil. Right, let's figure out. Put this up on the laptop just to confuse myself. So let's get the first one set up. I'm afraid it does start with a PowerPoint presentation. Plain. Everybody's lives. But not too long. This one. Right, so that's it. I'm just going to restart. Power. And hopefully we'll pick up all our screens this time. Right. Let's see. So, my name is Barney Nichols. I'm a developer at Headforwards, a company over at Hull. We're sort of based in the Innovation Centre and the open building on the campus over at Campbell. I've been there 3 years now, and I've been learning every day. I learn something new, and trying to keep going that way. So I hope you'll learn today how to use PowerPoint. Right. So I'm going to talk to you about image classification. So this is where we have a computer model that's trained to recognise the difference between images. It's something we all do every day, but has historically been very difficult for a computer to grasp. So this isn't necessarily what I do for a living. I write software. I don't do much in the way of machine learning at the moment. So I'm going to talk to you about where my journey with machine learning began, where I've gone with it, what I've learned with it. So we work for a big client. They're an insurance company, and they receive lots of letters. They receive thousands of their letters a day. These letters arrive in the building, and they go to this front office. Somebody opens the letters up. They take the letters out of the envelopes, and then take the letters, stack them, they then feed them through a scanner, and then they've got image to scan, so now gone from a letter to the scanned image. The scanned images are then uploaded into the cloud, and then they're shown. There's an event, so the first stage they're uploaded to the cloud, but the computer doesn't know anything about it. It's still just an image. It's just a collection of pixels. So I worked on a project for the best part of 2 years where we wrote the software for this person you can now see in front of you on the screen. So their job, day in, day out, is to sit in front of a computer screen. And on that computer screen, they're shown these pictures. Okay? And their job is to say, what is this? Okay? So they're looking at these pictures and going, well, that looks like an invoice. That looks like a statement, a medical record. There's lots of different types of information that's coming through. It's all just scanned and just arrives via the mail. So it's just shown to them on the screen. So we wrote a piece of software that would allow them to, using keyboard, to say, right, that is an invoice. That is a statement. They then look at that image and also say, oh, right, there's a membership number in there. I'll enter that. Or there's a group number. So this is all a very manual, very slow process. Potentially prone to errors and very boring, I'd imagine. So the next stage is that person then has classified that document. That document has now said this is an invoice, this is a statement, and maybe some additional information. And that then is sent on to another person. And that person then is sat in front of the keyboard. And they look at the document and say, ah, right, that is an invoice for that company. They're allowed £2,000 a year. If under the £2,000 limit, they can pay. And it's a very repetitive process. And they're just taking the information off the screen from the images. To me, it seemed like there must be a way of doing something for this. And it's not just one person doing it. Not two, not three, not four. They've got about 2,000 plus people doing this every day. And the idea I had was not to take this job away from people, but you take away the simple things. You take away the drudge and then give them something more interesting to do. So we have what's called a ship it day internally, where we're allowed to spend a day developing something that we believe might be of benefit to the company. So that can be either a practice, a process, or some software. So I was thinking that there must be a way we can improve this current process. I was writing the software that they were using to do it manually, but I thought there must be a way we could do this in a more automated procedure. So I've never actually seen production data. I've never seen what they get on their screens. We only ever use test data. Because the production data is live people's medical records, etc. So as a developer, I don't want to see it. Don't need to see it. So I just thought, right, let's go and have a look at documents. So I went and found some invoices, some cash benefit claims. And you see here's a couple on the screen there. And you can see they look different. So now there's a group of them. So you've got like half a dozen of each here. And you can see they're all different, but they all share some characteristics. So this is, shall we say, a training data set. You've got 6 of each here. Okay? So if I was to give you an unknown document, you can look at that and you can't see the details. It's too small. There's nothing really there. But if I was to ask you, is that an invoice? Or is that a cash benefit claim? I'd like to think, as we say, well, that looks more like a cash benefit claim than an invoice. There's a probability, a high probability of it being a cash benefit claim. You're not 100% sure, there's a high probability. So at that point, you've classified a document. And if you believe the probability was too low, it could go to human to classify, or it could automatically go on to the next stage of the process in an automated way. It says 95% sure, just let it go through. So, think I've just trained you as neural networks to recognise and classify images. So this is a neuron, which is the classic way of describing a neural network. It's how your brain works. Computers aren't quite like that. This is a diagram of a very simple neural network. So what a neural network tends to be is built up from multiple layers. You'll have an input layer, some hidden layers that do processing of different things, and an output. The input layer would have data coming into it, through the training stage especially. This would be something like this, in case it's faces. The layers then start doing their own jobs. So they start to start off with very simple things to start with the first layer, for instance. So here we're just creating simple, is that a horizontal or vertical line that you can see in this structure? That then collates those and will pass on to the next layer. This layer would be able to put some of these definite things together and create something a bit more abstract, like eyes, ears, nose, mouth. And then the next layer would take that abstraction further. Now you're starting to recognise how the whole face is made up. It's been made up from little tiny sections and then builds these layers out for abstractions. And then hopefully you'll end up with something that, once trained, can identify faces for you, to recognise faces. So it's a very simple way of how they work. So if you wanted to make your own neural network, how would you do it? Well, you could buy a book. I know a man who wrote books, very good. And I recommend reading it. But we're not going to do that today. It's brilliant. So I was looking around how to do this, and I didn't want to write this from scratch. So I came across a product you've probably all heard of, Tensorflow. So Tensorflow was created by the Google Brain team, and it was only released as open source in November 2015. It's less than 4 years old. So we're still at the very early stages of this exciting technology. It's a symbolic math library for data flow and differential programming, which is a way of saying you use it for machine learning. And I think that's what everybody understands it's used for these days. But TensorFlow itself is very low level, and I didn't know enough to how to actually jump in and start using this. So I found a model called Inception. So some of you know the film, where it's all about imagery and how things are done, images. But it wasn't created for that. It was created as a model by Google to enter a competition, the ImageNet Large Scale Visual Recognition Challenge. So this is where many different companies take a model, a neural network they've trained, and then will attempt to classify some images. There's about 1,000 categories they're classified against, and they start with large data sets to train their images on. The initial training data set, I believe, has 14 million plus hand annotated images. Images say this is definitely a shoe, this is definitely a cat. The training test and validation set has about 150,000 images. These are big areas of information. This is a diagram of the Inception model. Each of these, remember our earlier diagram of the neural network? This has many more layers. Layers that go back, feed back onto themselves, layers go forward. It's all a lot more complicated than that simple and it's easy. But it works in a similar way. You input your data. It rolls through the network, and hopefully at the end you get an answer that you're expecting. So, I was there and thinking, this is brilliant. This is trained to recognise these 1,000 categories. My invoices, my statements, I'm not in those categories. What am I going to do? I don't want to rewrite that. It's too complicated. So, I was going to use what's called transfer learning. It's where we take a model, like an Inception model, and instead of rewriting all that bit and training on than 14 million images. You just retrain the embryo. You just change the classifier. So the model itself can recognise structures and abstract patterns, and enough to build up ways of recognising and classifying images. So this was the proof of concept application I ended up creating. It was able to, with the training data that I found, able to fairly reliably classify invoices and cash benefit claims. I also extended it slightly and added some OCR into it, so it could recognise the text from the images, and then some regexes to extract information like membership numbers and claim numbers from it. So this potentially could then have been extended to go on to the further stage I'm talking about, where people have said, that's a invoice for a customer, cover the allowance, yes, 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 it could go through. The company, the insurance company, are very interested in it, and we may go further with it, but it's not going further than that at the moment. One of the things I learned when I did this is about 2 years ago. The documentation wasn't so good, there wasn't so much information around. The training, you would have to guess what the errors were about. It could be a bit difficult sometimes. One of the ones I had was I didn't have that many real images, so I needed to create some more. I only had 10, 20 images for each classification, so I just duplicated it, just copied and pasted them back in. Instead of getting an error, it happily trained itself and worked against my test training data set. Now there are ways of doing this automatically. There's the Keras have a function call you can take a couple of images. It will then stretch and manipulate the image so it actually creates more test data for you, even using simple small data sets. So there's lots of ways this has come on since I did this. So I'm going to talk to you about what I did using the inception model, but we are now going to use Tensorflow directly. So it's time to get your hands dirty and actually write your own first neural network. Okay, it's going to be not too difficult, hopefully, because we'll just be using a Colab that's online, hosted by Tensorflow, and we'll then work our way through the whole thing. Alright, so if you put that address into your browser,
Yes, sorry. Oh, that's okay. Hold down quietly.